Hello, everyone. Welcome to UTA Planetarium live stargazing or star stream show on this great Wednesday afternoon,
It's
1
Ask an
o'clock.
Astronomer, Levent. What are you doing?
Ask Astronomer. We keep changing the names of the shows. I cannot just follow anymore. The Friday one is called Sky Update still, right?
What? Yeah, Friday is Sky Update, and Wednesday is Ask an Astronomer.
Okay, well, it doesn't matter. Let's welcome to Ask Astronomer. My name is Levent Gurdemir. I'm UTA Planetarium Director, and here Jim Bader, the program coordinator, is with me in the studio today, and we have a lot of content lined up. And let's start
Yeah, it
with
should be
the
action packed.
first one.
All right, so first thing we're doing is announcements. We don't really have an announcement this week per se, but we did have some stuff that we kind of wanted to talk about. As usual, many of you guys know that we always post something in the discussion page that we want to talk about, something relevant to our expected subject matter. And this week we got a lot of engagement from you guys. So I think importantly, thank you for your engagement. Really appreciate that, as always. So I just wanted to pop in and talk about that if we have time. Levent, I think this is interesting, and I think you'll find it relevant.
Mhm.
And it looks like we have everybody here. So I'm going to bring this on screen. You guys can't see it, but Levent can. So you're going to have to bear with us as we move through this. Um, so the question that I asked was, other than a planet with life, what kind of exoplanet discoveries would you most like to see? I thought this would be a good question because we have some new exoplanet stuff to talk about. And Brexton commented and said the moons of other planets in the solar system. So this isn't really exoplanet, but I mean, what do you think about finding life somewhere else in the solar system, especially other than a planet? Is this something you think could even happen?
Well, yeah, we always talked about, the two possible places beyond planets, even like moons. But let me give you a little bit the history. When Voyager missions first started flying in the solar system and getting close to some of the planets and moons, Saturn's moon, Titan, excited the entire scientific community because
Definitely, it
the
did.
Voyager images and data showed an atmosphere around Titan. So there is a moon in the solar system, and the moon has an atmosphere. And more excitingly, this atmosphere was blue atmosphere, just like the Earth's atmosphere as seen it from space. This created an excitement because we thought that, oh, maybe there is another like alien place, and it's a moon in the solar system. Well, soon after, it turned out to be just a methane atmosphere, and also there was lakes on the surface of Titan, and we found out that they were methane lakes. Like methane is a highly explosive gas, so even if you like ignited like a cigarette lighter around Titan, I don't know what would
Well,
happen.
would
Probably.
there be enough oxygen to let it really ignite?
Uh-huh. But after all, yeah, that was exciting. But that was not the only planet. So
Or
for
moons?
the past decade, we are thinking about Europa,
And
uh, the,
Enceladus,
the
same, right?
the second largest moon of Jupiter, and also we are looking at the fifth largest moon of Saturn, Enceladus, because they both are covered by thick crust of ice. But this ice may be warm enough to melt and form liquid water in the inside of the moon. So in this case, it's pretty much like our frozen lakes on Earth. There may be a liquid water
Some Lake
covered by
Vostok
ice.
stuff going on.
Hmm?
Some Lake Vostok, that super deep lake in Russia.
Exactly, exactly. So those are the other destinations we need to look for after we are done with the Mars, probably, because still we are looking for an underground life on Mars, and Jupiter's Europa and Saturn's Enceladus will be the next objects, the point of interests for the
I agree,
future.
definitely in the solar system. So, um, uh, that was relevant to
Uh-huh.
exoplanets. I will say Brex's comment. Lamia's a little more on the track that I had imagined, though, and talks about classification of exoplanets. As we know, there's different types of exoplanets.
Hmm.
I'm just like there are planets here on Earth. But then moves on and says that she would be interested to know about other planets with Earth-like atmosphere and ecological systems. Now, this is a great question, but I want to add in there or really direct at you. Um, this is something we hope to see with James Webb Space Telescope, right? Is
Hmm.
looking at the gases that make up the atmosphere around these planets.
Hmm.
I mean, what kind of comments do you want to add to that? That's really interesting.
Yeah. Well, I don't think we have a determined classification for exoplanets. I hear terms like, super Earths, for example, came up about 10 years ago, and they considered some the planets close to the Earth size, but still much larger, super Earths. The first detected exoplanets were pretty much like our gas giants, Jupiter, Saturn, Uranus, and Neptune. But yeah, the one of the interesting things to find out is some of the planets we were able to tell from the spectroscopy. They have some layers of gas around it. They have atmospheres. So these atmospheres, well, we are, for some reason, the psychologically, we are always looking to find the exact same identical planet of our Earth
Because we know it
to
works.
say life. But life is actually, I think life can emerge on different conditions as well. For example, one of the interesting evidence is the Mars, the probably the Mars hosted life in the first place in the solar system, and then possibly it migrated to Earth as the conditions on Mars decayed, and the conditions on Earth improved as the star aged, as the sun aged. So similarly, if you think about Mars, it's a very different planet than Earth. It is smaller. The atmospheric conditions are similar. The temperature is different. So maybe there are other planets in other star systems that may have different conditions that may allow life. So I mean,
Agreed.
and always when we think about life on another planet, we are thinking like the humans can live there, but that may not be the requirement. So humans may not live because of the conditions, but we know on Earth there are some species that can take extreme conditions, like when the dinosaurs killed, some of the species survived because they were stronger than others.
Mm-hmm.
And maybe the most strongest species can live on different planets with completely different conditions.
It's certainly interesting that we don't know what are all the
Hmm.
possibilities. There's too many to just.
Hmm.
Next one we have two more that we're gonna quickly
Yeah.
burn through. Janet talks about planets being alive, and by that I'm assuming, and if she's here, she can definitely elaborate in the comments. But by alive, I'm assuming that means there's life on the planet. Are they changing? And I don't know if you want to elaborate on that. Similarity, difference between Mercury and Earth,
Hmm.
or Mars and Earth for that matter.
I think we are the main reasons for Earth to change, but also the climate conditions. Regardless, I mean, we have some significant effect on the climate change. If this is the change we are talking about, but also Earth is coming up from an ice age, and it's been through different ice ages before we know from the geology,
Mm-hmm.
and yeah, the planets are changing climate wise. And also last week we talked about we have evidence that the Earth's magnetic field or Earth's spin axis was actually upside down at one moment. So and it came back. So they can prove
I
it with
don't
some
think
of
I
the
saw.
stones in the. There was an article I think we discussed. If not, so
Maybe.
there was a new finding of they looked at the certain rocks, and the certain rocks at some point on Earth showed a some type of footprints of the ancient magnetic field, and they found it in the tipped over positions. I mean, we can only explain the magnetic field patterns of these rocks with the tipped over magnetic field, and they estimate some time, it was very long time ago, the Earth's magnetic field was tipped over and it recovered back. Why? We don't know. but this is something that could happen. Earth. So yeah, the planets are changing, and some of them are, changing the rotation axes, and this results in the climate change. The climate change is also affected by many other things, but if they are species living on it, and especially people like humans live on it, because they cut the trees and consume a lot of things, a lot of resources on the planet. The species, in my opinion, are the most significant changers of the planet.
The species, and then I think if there's going to be life, then the planet itself has to be active to some extent. I mean, there has to be some kind of internal activity. Otherwise, it goes dormant. It turns into a Mercury, nothing's going on, or Mars, where there's just not enough going on for there to be heat.
Well, the planet needs energy, and the energy mostly is, some energy is coming from the sun in the form of light, and some of the energy is coming from underneath of the ground or interior of the planet. That's all the volcanic activity that supplies and carbon and necessary the elements for us to survive. If there's no energy production, if there's no heat in the planet, if there's no heat coming from outside, then the planet would not be active and dead.
Well, the last thing that's brought up is from Kurt, and I thought it was a really interesting comment. It says, a planet suitable for terraforming to help us expand our footprint in the universe. So I think what it means by, when I said discoveries, he's saying discovering a planet that we could terraform. Terraforming, that whole concept is wild, and it feels like a stretch to me personally, but I don't know if you have a comment you want to add to that.
The NASA's last rover, Perseverance, one of the function is to produce oxygen on the surface of Mars. So apparently they are just scratching the surface to find out whether they can habitat some planets for life. So
definitely would.
Yeah, it's been researched and it's been in the experimental stage right now with the Perseverance.
All right, so we have a couple comments. We have a moment to jump to them. If you want to very quickly burn through this, we're already pushing time. So Brexton asks, do you think we will ever get to other planets outside the solar system?
The get to means like in person? No, because we don't have enough lifetime.
At least the technology is also currently not there.
Yeah, technology is a different dimension, but the going to different planets with a let's say NASA space shuttle or SpaceX spaceship, based on the speeds we can achieve, that would take millions of years to go to, even go and look around and discover nearby objects. Even in traveling in the solar system is not likely for humans, besides like we went to the moon, and we know how challenging to go to Mars. For a spaceship or space rocket today, it takes 9.5 months to go to Mars with just the machine only, no man's inside or woman inside, right? And the problem is, if we would like to man or woman this mission, 9.5 months you need to survive in a spaceship one way. Coming back is a whole different story, but how are you going to support somebody physically? 9.5 months. I mean, can you imagine how difficult it is?
A huge step. People are working on it, though.
We are not only talking about oxygen supply and food supply. We are talking about all imagine yourself living in 9.5 months.
We just did this.
No, I don't think we could.
No, we did it. But I'm making a joke about during the beginning of the pandemic, I just stayed in my house for, other than groceries, which is exactly what you
went
mean.
outside. I mean, your utilities still worked, okay? Your trash was still picked up on time.
That's the real problem. What do you do with all your waste? And by waste,
whenever
I don't
you
just mean
wanted,
trash bags.
whenever you wanted, you walked outside. You had internet. You called your friends. That's nothing like that. We are not talking about that type of being locked down.
All right, last little thing before we get into our main content was from Lamia, who says, it would be interesting for something like methane-based. This is about you talking about life forms and other, looking at it differently. For methane-based or CO2-based life or forms of life, but until now, I think in best chances we can find alien cells. But still, the large distance in the universe and our very small speeds, which is what you just covered, make a real barrier for us to explore.
Yeah. Can be
Very well
methane
said.
based. Well, we humans are carbon based, and the next element we are looking into that, which is the closest element to carbon, is silicon. We do not know if silicon based life exists, but if it did, that would be very different species. Can take many different conditions. Maybe they can survive in 2000, 3000 degree environment. Who knows? But that would be certainly different. But all the life on Earth we know of is based on carbon, which is
That's-
actually very abundant element in the
Yeah,
universe.
very
Is
wild
it
for me.
I think if I remember correctly, fourth abundance element in the universe is
It
carbon.
would make sense. I mean, in terms of stars, right? I think it
Yeah.
would make sense. All right.
Carbon is all over the place.
Yeah.
You can make species as we know of anywhere in the universe.
Very interesting.
All right. What is next?
All right. Next is main content.
Main content, exoplanets.
Yeah, we're gonna talk about exoplanets. Lots about exoplanets. You did some research that kind of covered a little bit of exoplanets, right?
Uh-huh.
All right. Which might help for today's content. So, without further ado, let's just jump right into this.
All right.
So,
I see an observatory.
yes, we have a newfound baby exoplanet photographed from more than 400 light years away. And this is a special type of photograph, right? I thought this was really, really interesting. So, this telescope behind you, I don't know if you want to talk about it at all.
Yeah. Well, I never been to that observatory, but that's a telescope in Hawaii by Hawaii Institute of Astronomy Subaru telescope. Like you know the car brand, right?
It might be right behind you, actually.
Exactly.
Slide out of the way. I think the
Is it?
no, it's not.
No, it's not.
Sorry, I
There's
played with your
also
emotions.
Seven Sisters, the Pleiades star cluster is called Subaru in Japanese culture. Anyway, Subaru telescope and the researcher Teruyuki Hirano discovered a baby exoplanets. What we mean by baby exoplanet?
Yeah, what
It
does
is
that mean?
forming, already forming in the formation process. It's a young exoplanet spotted. So the most significant part of this is a direct image, not like the artistic rendering or reconstructed from data. So this is a direct photograph.
Yeah, that was really interesting to me that they just, in a way, they just pointed a camera and snapped a pic.
And the reason we were able to photograph this and not others, this is probably in the stages of still hot lava that glows the planet, and the pretty much like when it is orbiting around the star, it is still consuming some gas around it, so it makes it a little bit like orbit. For that reason, we were able to spot because it glows nearly in the visible range. And with a powerful telescope, and hopefully we'll be able to discover more with James Webb is in place.
Definitely.
And it is named not excitingly like any other exoplanet. It is named 2M0437b. What
So
does that mean?
romantic. Wow,
So what does that mean is the 2M0437 is the name of the star, and exoplanets are named, gets the letter designation starting from B, not A, and the small letters, not capital letters, B,
Would
C,
A be the
D,
star?
E, F, G, as the in the order of the discovery. So the first discovery is gets the designation B after the star name, and star name is 2M0437, which is happens for dim stars. They don't have exciting names like Sirius, Betelgeuse.
It doesn't make it any less ridiculous.
Mhm.
Very, very awkward.
It's not very far, about 400 light years away,
That feels
which
far.
is, I mean, of course, if you want to go there, it's very far. But in the astronomical scale, if we consider the dimensions of our galaxy, it is pretty much nothing. You cannot just distinguish or point with your finger where the Earth is and where this star is
So
if you are looking at like a universe map or the Milky Way map.
in this picture, Levent, it looks really close to the star. But research said otherwise, right?
Well, they say it's about 100 astronomical units, which one astronomical unit is the distance between Earth and the Sun. Nearly 150 million kilometers, or close to 100 million miles if you are using standard units. This is 1 AU, astronomical unit, but this is 100 AU, which is 100 times of that. And if we just put this planet in the solar system, it would go twice as far as Pluto. So it's quite far to the host star.
All right. So, quick questions we have or comments we have from. Looks like Lamia said fancy nomenclature. I think in regards to the name of it, and Brexton says, with so many eruptions going on our planet, are we still in a new planet age? Or are we getting old? And I think he's talking about because this planet is supposed to be like 3 million years old.
Yeah, the 3 million years is pretty much it at a baby stage. We can consider it like maybe a day old infant with our human scale. But our planet is 5 billion years old. So our planet is pretty much in the middle age. If you again consider it maybe a person, it may be like in the mid 30s, if not 40s, or maybe I don't know, somewhere between mid 30s and 40s, let's say.
50s if you're fortunate.
And 5 billion years old planet, yeah, we still see eruptions and everything, but that's not related with the formation of our planet. Our planet has completed its formation. Yeah, it is still evolving. That's a different story. But all the activity inside is mainly coming from because interior is active. And one of the most important things that keeps our planet's interior active is the moon. As the moon orbits around Earth, it results into tides, right? I mean, it causes a lot of, the movement, the water movement on the surface of our planet. It is also causing movement in the inside of planet where lava is molten. And that movement keeps the planet's interior active. That's why we
Very
think
important.
Venus is not as active as Earth.
Certainly interesting. We have some responses to you, Levent, that are very relevant. Definitely were hurting me as we were going through this. Kurt says I have a Chihuahua older than that, and Brexton says I'm 63. I'm older than the Earth. I don't I don't know. I think that's kind of like dog
So
years.
that's on
Earth.
top
That's what
of
they're
5 billion, 5 billion plus 63.
Hey, they're relating it to the lifespan of their life. Brexton's saying that he's older than the Earth relative to the Earth's age.
Well, it doesn't matter. It is how you feel, right? How old do you feel?
Yeah. That's ridiculous. Okay, well, those were really good comments. I think we're ready for our secondary story, which is very relevant because looking at this picture, this wasn't. This was a direct image, right, of a planet going around a star.
Yeah, that's amazing.
That's not what we typically do, right?
No. Well, the stars are far away, and if we compare the planet size, that's gonna be like a very small one, not like huge. This one, the planets are very far, and the way to find them, the most planets are found by Kepler satellite, and that was a planet is going in front of a star, and this planet blocks some of the light, right? Some of them, not entirely, but small portion of the starlight is blocked. The Kepler satellite was sensitive enough to measure this brightness drop. And that's how we found out most planets. There are some other types of techniques that we can find the planets as well, but the direct imaging was never possible.
Yeah, yeah. But the good news is that indirect imaging is what we typically use, so we're good
Mhm.
at it. What I think is really interesting is that we may have found a new way on
Mm.
accident to find exoplanets, which I think is pretty spectacular. So let's jump in and show you some of this interesting data that we have here. There was a study
Mhm.
from Nature, which is a popular publication for
Very nice
science papers.
publication.
And the title of this paper was a little confusing to me, and by that I mean I just really
Mhm.
didn't like the title of the paper. It was called "Population of M dwarfs Observed at Low Radio Frequencies." Uh, this paper studied 19 dwarf stars that were emitting radio waves. Now I can ask
Mhm.
you, is that normal?
Well, let's first comment on the M dwarfs. What does that mean?
Sure, yeah, that's probably a better place.
That's a star classification, and interesting enough that dwarf is actually means normal star. Our sun is a normal star, and that's called dwarf. And dwarf stars are burning hydrogen. And after a star formation, what we see is the star is living its life, consuming all of its hydrogen, and going to different stages after hydrogen runs out. And after hydrogen runs out, then the star goes into different stages depending on how big the star was to begin with. And it can be a giant star, supergiant star, explode as a supernova, or die as a brown dwarf. So the M is the coolest classified stars. They burn on the surface about nearly 3000 degrees, which is considered very cool stars. And when we look at the sky, we see these stars as red stars. So M dwarf means just the like our sun, normal star, hydrogen burning star, but it is in the red and cool category. It turns out 80% of the stars in our galaxy are M dwarfs. So population-wise, they are the dominant stars. Do you know what's the percentage of the stars in the Milky Way are just like Sun,
No.
G stars?
Uh,
It's about 3.5%, very small.
okay.
And even if we go to hotter stars like OBA stars, the percentage of the population goes well below 1%. So with that said, so what's the radio emission? So I was actually excited to see this article because that reminded me my graduate research at UTA. Well, I was working on a planet-induced activity. I was trying to prove that because according to the theory that came before, and I was trying to prove, is a planet is orbiting around a star, and the idea is when during this orbit, the planet induces some magnetic field on the surface of the star, and this causing some the warmed up surface due to magnetic field. So this warming up results or may result in increased star activity, and that activity is expected to be some flares, coronal mass ejections, etc. Anyway, we in the scientific community, like my research was followed by a very small number of scientists. And there were also people who were expressing against negative opinions about this. For that reason, it took for a long time to discuss this, and but the number of observations were not enough. But now it seems like some other group of scientists are trying it from the different perspective, and they are using, and when I mean say perspective, it is really perspective, because they are using radio waves. My observations were optical. I did my observations at the McDonald Observatory located at West Texas, and they are trying radio waves, which is very clever. And if they prove the radio emission emitted from these stars are correlated with the planets orbiting around them, and that will be a new discovery for science, because then we will say, yes, the planet really induces some activity on the surface of stars, so planet hosting stars are more active than not non-planet hosting stars.
So some of the things that we picked up from this was that of the 19 stars that they studied, they said most of these stars are big enough and active enough to be emitting radio waves of some kind, as stars emit radio waves. But 4 of these stars were small enough and not active enough to be expected to emit radio waves in the way that they were. That's like the gist of the study as it goes on. But the implications of that, like you were kind of touching on, I think, because you know a little ahead of this, but you were kind of touching on the implications of that. Before we jump into the implications, I just want to talk about how it was discovered. It was discovered with a radio telescope called LOFAR. LOFAR is a really cool. It's spread out like all over Europe, and it's pretty big. I think the effective spread was pretty big, right?
And the spread is certainly all over the Europe, but the reason of the spread is they are using a technique called interferometry. And with the interferometry, instead of you are building a gigantic telescope, with the radio waves, because the radio waves can be combined, if you put your radio telescopes or spread your radio telescopes over a surface, when you combine the signals from these different radio telescopes, you get the same results as you had a telescope as large as the continent Europe. So for that reason, they spread the telescopes. Instead of building a gigantic radio telescope covering the half of the planet, they just spread a small amount of telescopes, combine the signals, and then get the giant telescope result.
You get an effectively 2,000 kilometer wide telescope. This
Exactly.
is an image of what the telescope looks like. This is just so cool. They look so futuristic. These little patterns or chunks all look a little different, but they're just spread out all over Europe, and that makes up this telescope. So. We did an episode about telescopes. We kind of talked about radio telescope arrays. We didn't mention this one, which maybe we should have. Super interesting.
Yeah.
All right. Let's get into the implications of that study, because we've seen radio emissions from stuff that shouldn't emit radio emissions in the same way. And the best example of that was from largest planet in our solar system. So this is really interesting. We see the radio emission come from an aurora, a peak in the aurora over here. And that peak in the aurora is exactly what you were mentioning. It's playing with magnetic fields. I don't know if you want to elaborate on this. This is wild.
Yeah, well, we see Jupiter, aurora on Jupiter, like aurora on our planet. And yeah, when there is a magnetic field and highly charged particles spreading around, excuse me, these highly charged particles are being trapped by the magnetic fields and follow a path and go down and interact with the planet's surface, which in our planet, in Earth case, there is atmosphere. In Jupiter case, there is the what is considered also atmosphere, but the surface of Jupiter. When these highly moving particles start interacting with different gas molecules, so there are collisions, and as a result of the collisions of the particles, most of the time some visual light is emitted, and this is what we see as aurora. And the aurora is a great proof of the magnetic field and the particles, highly charged particles, interacting with gas layers.
Yeah, and this interaction between Io, which is really, really close to Jupiter and gets tugged on a lot and emits gas, as we saw
Mm-hmm.
pictures of it, um, astronomers said, hey, if Io and Jupiter interact this way,
Mm-hmm.
and we get these peaks, which look really similar to the peaks we're seeing from these stars,
Mm-hmm.
are we seeing exoplanets that are causing these auroras? So I'm just curious. I know that this is conjecture, but what do you think? Do you think that this is a possibility for us to see an exoplanet indirectly once again, but
Mm-hmm.
through its interaction with the star's magnetic field, not through wobble and not through the light curve, which is what you mentioned earlier? Do you think it's possible?
Uh, well, I don't want to say nothing is impossible, but I do not know any direct method to doing that because the planets' magnetic fields are usually weak comparing to the stars. And if we were able to detect that, would be very sensitive, magnetically sensitive telescope,
Yeah,
I should say.
it definitely would. So I don't know. Maybe we get something. Not that James
Hmm.
Webb is very magnetically sensitive, but maybe we get more information. I mean, I think the next thing and the next step that I expect is papers coming out showing that you can see these interactions, and then papers coming out saying I looked at these four stars in
Hmm.
a different way and was able to identify that there are exoplanets, and they match up with the consistent patterns that we were seeing.
Hmm.
So the radio emissions were patterns, and that
Hmm.
that consistent pattern was somebody saying, just like with this image behind me here, you
Hmm.
can see that Io
Hmm.
magnetic footprint
Hmm.
move as Io rotates around Jupiter. So it
Hmm.
matches up with it at all times, and you always see that. So they're saying we even know where to look to find that. You can just follow that little flux tube from Io, which is pretty interesting. I don't know. Anyway, that's the article. I don't know if you have any more you want to
Yeah.
elaborate on that.
Well, I think we'll just keep an eye on the results coming in, but radio waves, especially, I think there's a lot of work coming up for radio astronomers. We last year observed the unfortunate destruction of Arecibo telescope,
Yeah.
but
Oh no.
that was an old telescope, and we are fortunate to see the new telescopes, the radio dishes, radio antennas being built for astronomical purposes, and they will certainly give us a lot of clues. Because again, as we said, the 80% of population are M dwarf stars in the
Mm-hmm.
universe. Um, and also, I think I see a comment from Kurt
Yeah, there's a couple of
about.
really good ones.
Uh,
Uh, if you want, if we're gonna jump into comments now, which I think
uh-huh.
is pretty good, we should kind of pop through all of these. But yeah, definitely let's start with Kurt. Um,
Okay, would you like to read that?
sure. Yeah. So, are the galaxies out there made mostly of Betelgeuse? Are there galaxies out there that are made mostly of Betelgeuse-sized stars, or is that size of a star always an anomaly?
Well, I'm not sure about other galaxies because we cannot usually only in a few galaxies we can identify stars. We are certainly um, doing some observations from outside galaxies, especially we are observing their supernovas. And because we call that standard candles, we are using the supernovas inside the galaxies to measure their distance. So this gives us a very good trick because the galaxies, the distance galaxies are too far to make accurate distance measurements. But if we catch a supernova, because we know a lot about supernovas and their brightness characteristics, we are doing great job about estimating the galaxy's distances. So the supernovas are related with Betelgeuse-sized stars. I wouldn't say there are not many of them uh, populated in the galaxies because we are not seeing supernovas all over the place like fireworks in the galaxies.
Yeah.
I would say in other galaxies, the ratios are pretty much the same with our Milky Way, which is 80%, nearly 80% is M dwarfs. Supernovas are special. I mean, the giant stars are special cases, and giant stars, supergiant stars, we are talking about 3 solar mass and higher stars, they end up with explosion at the end of their lifetime, and those explosions actually or are also scientifically very interesting and very important because they can give us a lot of clues about their nature.
Definitely. All right. We had some random questions we kind of skipped over, but we have time to just kind of quickly get to them. A
Yeah.
question from John Housley, who said, just joined the feed, but
Great. Hi.
were organic molecules found on Mars? Buddy texted me a bit ago, but haven't been able to read anything about it. Did you see any articles about this?
No, not organic molecules, because if you find organic molecules, then that means we found the pretty much, I think, the signs of life. I'm not aware of any organic molecule finding, but certainly they are searching for it.
All right. Next question was something we just got, but did also skip over, from Brexton, and it says, "Is winter time a great time to stargaze?"
Winter time is sort of better time for stargazing. At first, there are brighter stars and constellations happens to be in the winter sky, like Orion Nebula. Sirius is coming in the early evening hours. And there's also right above Orion, there's constellation Taurus, and inside of Taurus there is Pleiades, Seven Sisters, and many other stars. So it's the study show in the winter sky. Also, because the humidity is lower in the winter sky, usually the observation, the seeing conditions are greater during the winter. Sky gets darker earlier, so you have longer observation time, and plus there are no mosquitoes. That's also plus.
But it's cold, Levent. It's too
for
cold.
observing. Yeah, the cold is one, I think, drawback. But if you just get enough like warm jackets, put enough layers of coating, then I think we should be fine. I like observing winter better than the summer, because summer you have to wait until like 9:30, 10 o'clock to get the sky really dark, and there is usually humidity and there is a heat associated with it. Heat also is a problem on the optics, especially when the humidity is around, and plus mosquitoes are always problem for summer nights.
Definitely. All right. Well, that does it for our stream today, but we have more, right?
Yeah. Upcoming on Friday, as we promised, we are on YouTube, and we are going to talk about astrology. And we are going to talk about horoscope.
You should bring a costume, Levent.
We are going to talk about how people are making predictions for future fortune telling business, and also how they do character analysis and personal analysis.
Will you read our tea leaves? Will you read our tea leaves?
Oh, yes, I will bring some coffee with
coffee
me.
veins.
Yes, exactly. So we'll see you on YouTube this Friday. If you're interested in some astrology talk, bring your astrology fan friends too. Whoever wants to know more about astrology will be here to talk about this.
All right.
All right. See you Friday at noon on YouTube.